Hi everyone. Today I'm sharing a 3-year retrospective on building a personal AI workstation. Beyond just a hardware guide, this is a look at what worked, what I'd change, and why local compute is still a game changer in the age of LLMs. 3 years ago, I settled on this flagship build, an ASUS ROG Z790 motherboard, an Intel Core i7-13700KF, and dual liquid-cooled RTX 4090s. To power this setup, I chose a 2000 watts platinum PSU. Looking back, this remains a highly capable configuration for algorithm experiments and PyTorch development. I've included the full build specs in the description below. A key lesson: PCIe bandwidth matters more than the newness of the board. Most consumer boards split lanes in dual GPU setups, for instance, running at x8x8 instead of x16x16. While x8 is often enough, you must verify how your specific board handles data exchange for multi-card workflows. Cloud is great, but a local station offers unmatched flexibility and zero friction for rapid prototyping. Regarding the CPU, while Intel offers great I/O, remember that the choice impacts your data pre-processing speed. The goal is to create a balanced environment you fully control. The GPU is your biggest investment, often taking up 60% of the total budget before buying. Think twice about your needs. For me, while 48 gigs of VRAM seemed massive 3 years ago, modern video and high-res generative AI are pushing those limits today. I find myself using offloading techniques to fit larger models, so I'll aim for the maximum VRAM my budget allows next time. Never cut corners on the PSU. With dual 4090's power is critical. My 2000 watts PSU was a smart move, but remember the infrastructure. You'll likely need a 16 amps wall socket like an AC unit to handle the draw safely. Cables are the most overlooked part of a build. I highly recommend an ATX 3.0 PSU with native 16-pin connectors. It reduces clutter and lowers the risk of connection errors compared to using multiple adapters. Given the reports of melting 4090 connectors, cable health is paramount. My rule of thumb is to avoid sharp bends near the GPU connector. Keep the curves gentle to ensure a stable electrical connection and peace of mind during long training runs. Standard airflow theory is bottom in, top out. However, I learned to be flexible. For example, I removed the bottom fan because it was blowing dust directly into my hard drives. Effective cooling means moving air past heat sources, not just blindly following a template. Liquid cooling solves heat and noise issues for dual 4090s, but it adds huge complexity in tubing and air bubble management. Look at the picture on the right. I had to use pliers and metal snips to cut the internal structure of my case just to fit the radiator pillars. Your case is a system, and sometimes you have to engineer it to make your specific parts work together. Once assembled, use the motherboard's Q code display to monitor the boot status. This 2-digit indicator is your primary tool for identifying why a system might be failing to self-test. A major lesson I hit was code 55 memory not installed in my case. It was a ghost error. The RAM was fine. The real culprit was something completely unexpected involving the CPU installation. The fix for my RAM error is loosening the CPU cooler screws slightly. Uneven pressure can interfere with the motherboard traces to the memory slots. Finally, always check for thermal paste overflow before finishing your installation. This is what my assembled workstation looks like. And you know what? The image you're seeing here was actually generated using an AI GC pipeline running on this same machine.